Okay, so let's talk about AI, because right now we're living in a pretty wild paradox. You hear that AI is this energy guzzling monster that could be a total disaster for the planet. But then, in the next breath, you hear it's a sustainability miracle worker that could help save us. So, which one is it? Hero or villain? Let's unpack this, because the real story is way more surprising than you think.
You've probably seen those headlines, right? The ones that make it sound like every single question you ask an AI is another puff of carbon in the atmosphere, another drain on our water. But is that really what's happening? Is your curiosity literally boiling the oceans? Let's get into the real numbers behind the hype. All right, so first, let's look at the case against AI. Where does this whole climate villain idea come from? Well, it all starts with a simple, undeniable fact. AI has an absolutely insatiable hunger for power. And we're not just talking about the software, we're talking about the massive, physical, real-world infrastructure that has to run 24/7. Get ready for a staggering number. By 2026, the electricity needed just for data centers, which are the backbone of AI, is projected to shoot past 1,000 terawatt hours. Now, what does that even mean? It's more electricity than the entire country of Japan uses in a whole year. And that demand is only going up. This chart really puts it into perspective. You can see the base case here showing consumption pretty much doubling in just 4 years. But look at the high case scenario. I mean, if AI adoption really takes off faster than we think, that line goes almost vertical. It just shows you the massive scale of the energy challenge we're looking at. But here's where it gets really interesting. Not all AI is created equal. Check this out. Two huge language models, roughly the same size. Training GPT-3 pumped out over 500 tons of CO2. But training Bloom, just 25 tons. So what gives? It wasn't the AI itself. It was the power grid. Bloom was trained using a much cleaner, low-carbon energy source. This proves that where you run the AI matters a lot. Okay, so that's the scary side of the story. But what about the other side of the coin? The one where AI isn't the problem at all, but actually a huge part of the solution. You know, AI's superpower is its ability to analyze just mind-boggling amounts of data. And that's where its potential for good really kicks in. It can make our power grids way more stable and efficient. It can predict exactly how much energy we're going to get from wind and solar. It can even do what's called predictive maintenance on things like wind turbines, fixing tiny problems before they become big, expensive ones. And this isn't just theory. The numbers are already proving it out. Pilot projects are seeing up to a 15% jump in energy efficiency just by using AI. And for wind power, which is famously hard to predict, AI has improved forecasting accuracy by a massive 25 to 30%. That makes renewable energy way more reliable for everyone. So how do we square these two completely opposite narratives, the energy hog versus the efficiency wizard? Well, the key, it turns out, is to change our perspective. We need to zoom in, way in, from the global scale of giant data centers all the way down to the tiny impact of a single prompt you type into your computer. Okay, so what is the impact of one prompt? Well, Google recently did the measurements on its Gemini model, and the answer is 0.24 watt-hours. That is a shockingly small amount of energy. So small, it's kind of hard to even wrap your head around. So let's put it in context.
Think about it this way. For the same amount of energy it takes to charge your smartphone just one time, you could ask an AI somewhere between 50 and 70 questions. All of a sudden, that single query doesn't seem so bad, does it?
And it gets crazier. Let's talk about streaming video. The carbon footprint of watching just a few seconds of an HD video is actually bigger than asking an AI a question. A lot of the digital stuff we do every day without a second thought has a larger footprint. And now for the big one. A short, 15-mile round-trip commute in a regular gas-powered car, that single trip produces the same amount of carbon emissions as, wait for it, tens of millions of AI prompts. They're not even in the same league. It's not even close. So what explains this huge gap between the scary big numbers and these tiny little ones? It all comes down to one crucial difference: training versus serving. See, training a huge AI model is like building a massive factory. It's a giant one-time energy cost. But serving, that's just answering your prompt, that's like flipping on a single light switch inside that factory. It's an incredibly tiny fraction of the total cost. This quote just nails it. A single AI prompt uses about 5 drops of water for cooling the data center. 5 drops. Now compare that to the 12 liters of water it takes to grow one single almond.
or the 60 liters for one avocado. The difference in scale is just staggering.
So where do we go from here?
Well, it's pretty clear that AI's future isn't set in stone. It isn't automatically a hero or a villain. Its real environmental footprint is going to be the result of the choices that we, the people building it, make along the way.
So what does a sustainable AI future look like? It really boils down to three key things. First, we have to design more energy-efficient models from the start. Second, we've got to power all this infrastructure with clean energy. And third, we need to engineer the data centers themselves to be as sustainable as possible.
And this is already happening. Take Microsoft's SuperHUD in North America. It's a logistics warehouse, sure, but it's also LEED Platinum certified. It's got solar panels on the roof and these super advanced, hyper-efficient cooling systems. It's real-world proof that the physical infrastructure behind our digital world can be built the right way.
So in the end, the data shows us a really important truth. The impact of your single individual AI prompt is minuscule. It's a drop in the bucket. But the collective global demand for AI is enormous, and it's growing like crazy. The technology itself is neutral. Its final footprint is a choice. The real question is, how will we choose to build it?